here. Okay. All right. Let's see. Why am I seeing? Oh, I know what I have to do. I don't. I want to see my screen. All right. For some reason, I'm not sure. I got this new screen here. Let me figure out what's going on. Can you see my screen?
No.
You're not looking
Wait,
at
hold on.
my screen here? Here, let me do
Oh,
it.
now I am.
And now you're seeing it?
Yeah.
Um, okay. For some reason, I'm seeing a miniature version of it. Um, Let me make sure I can write. Not quite sure what happened. Um, okay. I guess I'm okay here. Not sure why it's small, but anyway, I wanted to finish up a couple of things that we were talking about last week.
Uh-huh.
A few additional things. Um, let's take this problem. Whoops. Oh, now I'm seeing duplicate here.
Oh no, that's not good.
Are you saying duplicate?
No,
Do
I'm
you see x
just seeing
squared or do
one.
you just see one x squared?
I just see x squared.
X squared? Huh, on my end, I'm seeing both of
Yep,
them.
that's all I see, and only one of them.
Yeah,
I think something's up with your screen, that's for sure.
what is going on here? Hold on. Let me see if I can blow this up. I do not know what I accidentally clicked on to get this like this. Um, what can I do to fix it? That is the question. Let me do something. Let me try something. I am going to stop. I'm going to stop sharing for a moment and then start sharing again. And maybe that'll fix it. So I'm going to stop sharing so you'll stop seeing my screen. And now I'm seeing
Yep.
you, but I'm seeing just a picture of you.
Yeah, I don't have my camera on right now.
Let me.
Yeah, I don't have my camera right now because I've been at sports practices all day and looking a little bit like a mess.
Let me try sharing again. Okay, that's solved it. I'm good to go here. All right. So let's try this again. Um, you know how to factor this.
Yes. Yes, I do.
Okay, it's x minus 4 times x plus 3. But this is the way you'll probably encounter it, like that, as an equation. And do you know how to solve it from this point?
Um,
If I said to you, here's an
wouldn't
equation,
I just
solve
move
for
the
that.
12 over minus 12 so that I set the whole thing equal to
Yeah,
0?
yeah. Whenever you're trying to solve a quadratic, you want 0 to be on one side of the equation. So if I subtract
Mm-hmm.
12 from both sides, then I've got the quadratic that I just had written, and it's equal to 0. And then we make x minus 4 times x plus 3 equal to 0, and then we can solve it. All right. So what happens if I make this a minus 3? Now you can no longer factor it by the quadratic factoring methods that we've talked about. In other words, I can't find factors of 3 that subtract to 1. 3 and 1 are the only factors of 3, so I cannot solve this by factoring it, which means I have to do what? In other words, if I list my order of things in factoring, I start with greatest common factor, and then I look for dopes, difference of perfect squares, and then I look to factor it quadratically, quadratic factoring. And if all of those fail, then the final thing is the quadratic formula. So tell me what the quadratic formula is for starters.
Um,
This is something you want to memorize. There's
yep,
various
yep. Hold on.
to
I know this
memorize.
one.
Okay, good.
Ah, um, is it the
Hey,
all over
I'm
two
gonna
a,
sing. Here's what I'm gonna do. I'm
or
gonna
is it
sing it.
wait
I'm gonna
ax
sing it to
squared
you
plus
to
bx plus c?
give it to me again.
Ax
No,
squared.
no, that's something different. That's the standard format.
Wait, no, I got it. I got it. I got it. B plus minus the square root of b squared something
Okay,
4ac
okay, you're close.
all over 2a.
Yeah, you're very close. X equals minus b plus or minus root b squared minus 4ac all over 2a.
Okay, because I don't know why all I can remember is all over 2a.
So
That's
they'll probably, you won't need to have this memorized for a while, but you will be forced to memorize it. When you take your SATs a couple years from now,
I had it memorized
they
for a
will not
while.
give this to
I just
you.
kind of
You will need to have this memorized. So whatever it takes.
and
Uh,
what grades do you take the SATs in? Is it just your senior year?
you can take it anytime. I tutored people in their sophomore year who were taking it. Um,
Huh.
you want to take it a few times if you can. So the earlier you take it, the better. The normal schedule is you take your PSAT as a sophomore, you take your SAT as a junior, and then if you want to take it again, you can take it as a senior a second time.
Now there's the ACT,
And then there's the
right?
ACT.
Or whatever.
That's pretty much similar thing. There's no PACT, but there's the ACT. And there's not that much difference between the SAT and the ACT. They're very similar. They're testing your algebra and geometry skills, the math portion. Obviously, there's a verbal component to both of them also, which tests your vocabulary and English and writing skills. But the only one I really work with people are the math portion. So if I had this expression up here and I said, okay, now let's turn it into an equation and make it equal to 0, and let's solve for x. How would you use this quadratic formula to solve for x? First of all, what is a, b, and c?
Um, A, B, and C, x squared
What's a?
minus x minus 3. Oh,
What's
x
a?
squared.
No, it's the coefficient of each of those terms. So a is 1. And
What? Oh, wait, I remember that. Oh, I don't know why I just blanked.
b
B
is
is also,
minus
it's
1.
-1,
And what is c?
-3.
So plug it in.
X equals 1, because two negatives, they cancel each other out. Plus minus square root of -1 squared,
Whenever you have a negative
or
number,
just 1, because you have the plus minus.
make
Or
sure you put parentheses around it. You would not want to write -1 squared. This means -1. This means +1. Okay, keep going. minus. I think
Hello?
I lost your audio for a second. How does that keep happening?
Yes, I lost the whole video and everything.
Are you seeing my screen?
Okay.
Can you hear me?
No. Yes, okay, now I see the screen. Now I hear you. Everything is good.
Okay, so what's next?
Okay. Um, minus 4, and then in parentheses, 1, close parentheses, and negative 3 in parentheses. All over 2,
All right, let's
and then
keep
just leave it at that because, we know 2
no,
times 1.
you don't ever want to leave it as this. The next step is to solve for what is called the discriminant.
Oh, no, I didn't mean leave the whole thing. I meant just
Okay, so let's
leave
keep going.
the
Keep
2.
going. What's everything
Um,
inside the radical equal to?
yeah, yeah. Um, negative 1 squared is just 1.
Okay,
Um, and then 12. Because negative 4 times 1 is negative 4. Negative 4 times negative 3 is 12. So 1 plus 12.
okay. Can that square root of 13 be simplified?
Um, no.
Okay,
Wait, can it be?
no, it's
No.
a prime number for one thing. If it's prime,
Yeah, for 12, you would split it up into 4 and 3.
yeah. Okay, so you know how to solve now every quadratic that they can give you. If you can't, these three ways are considered far easier than the quadratic formula. So if you can do it by greatest common factor or dopes or quadratic factoring, do it. If you can't do it by any of those three methods, then use the quadratic formula. And that's the way you solve them. All right, so let's talk about uh, graphing quadratics. Now, hold on. While we're talking about this subject of whether that can be simplified, let's discuss that a little bit more. Um, how about this one? Can that be simplified?
Yes.
To what?
4 and 2. So you'd have 2 plus minus the
Actually,
square root of 2.
it's just that. In other words,
Oh, sorry.
what you do with these is the following. You say that the square root of 8 is equal to the square root of 4 times 2, and that's equal to the square root of 4 times the square root of 2, and that's equal to 2. So you end up with 2 root 2.
Square root of 2. Yep.
So whether or not that can be simplified is determined by whether it has a factor that is a perfect square number. How about this? Can that be simplified?
Um, no.
No, it can't be because I can turn it
Because
into,
every factor of 10 goes down to the same problem of it can't be
well,
rooted.
I can turn it into these two, but that's not simplified. That's two radicals
Yeah,
instead
that's
of
not
one
helping
radical.
us at all.
So it can only be simplified if you can pull a whole number out. So how about square root of 50?
Yes. 25 and 2. And then
Okay.
you have
You're,
um
you're fine. You're
yep,
fine on
that's
these. All right.
you beat me to it. I mean, I was assuming
So
that you know
if you
that
know
I
how
can
to do
do
them, I'm not going to
square root
spend
of
time
25.
wasting time going over the subject. I'm looking for what you already know how to do and what you don't know how to do. So first of all, when do you start school?
I started sports and debate this week, and then school
When do you
starts on the
start math?
20th.
When do you start math class?
Let me check my schedule because I don't have math every day. So let me see when my first math class
Are we
is.
talking 1 week, 2 weeks, 3 weeks?
Let me see because I don't
I
know if
don't
I even
need,
have
I
math my
don't
first
need
week.
to
I think
know
they might
this.
have pushed it.
I don't need to know the specific date. I just want to know how many sessions we're going to
Yeah,
have.
I'm just seeing what week it's in. Well, my school starts on the 20th, so let's say 2 weeks.
Okay. So once you start school, you'll be bringing me problems, and that's what we'll be working on. Up until then,
Yeah.
I'm
And then once
figuring
school
out
starts, it
the
won't
syllabus.
be, sorry. Yeah, and also once school starts, like it won't be um weekly. It won't be like every single week because there will be
That's
some
fine.
days.
I'll unlock that Thursday night opening and I will just do it whenever you request it. Um, that,
All right,
yeah, no problem. Uh,
like I'll have certain days
yeah,
where once school starts, I've got volleyball every day till like 5:30, and I live an hour away from my school.
all right. So
So,
you'll have to
and
figure
I'll
out a
have like
schedule that works for you.
I have these random days where I have huge, just open blocks. And when I say huge, I mean I'll have 3 hours between classes on Thursdays. Funny enough, I have on my first week of school math, the 22nd, and I have a 2.5 hour open block for my math class. So I might see if I can schedule for then so that I could like get some final like help on
I'm gonna
seeing like my homework and
I'm
stuff.
gonna be severely limited because I play bridge every day, and I either play in the morning or I play in
What's that?
the game of bridge, the card game.
I've never heard of that.
No, just a card game like poker,
Ah, okay, it's a card game. All right.
playing cards. All right, so let's talk about various formats for a quadratic. The most common one, the one they're going to teach you the first one is this one. You've maybe already had this. And an example of this would be y equals, let's say, 3 times x minus 4 squared plus 5. So they might give you a quadratic that's in this format. And notice you have an x squared. You're going to have an x squared and you're going to have a y. So anytime you have an equation that's got exactly a y to the 1 power and the x squared, it's a quadratic. And this is the most standard format. And if we graph this, the most important quadratics are parabolas, okay? They either look like this or they look like this. Am I telling you anything new?
No, we already went over this in one of our other sessions.
You and I did?
Yeah.
Okay. Um, okay, so that's the vertex format, is this one at the top. And you also have the intercept format, which is this one. And here you use P and Q, which are not the same as H and K. Up here, H and K are the X and Y coordinates of the vertex. In other words, when you're looking at a parabola, this is the most important point on it. And H is the x coordinate of the vertex, and K is the y coordinate of the vertex. So that's one format that they want you to know. Another format that they might give you a problem in other words, they might tell you that y equals 3 times x minus 4 squared plus 5 and ask you to graph it. And the way you graph it is you find the vertex based on what h and k is. Once you've graphed the vertex, then the rest of the graph is relatively easy. The second format is called the intercept format. And what P and Q are your x-intercepts. This would be P and this would be Q. And you might get an equation that looks something like this. X plus 1 times x minus 1. So your P, if I were to graph this, I would know that one intercept is at -1 and the other intercept is at 1. And y or a is a positive number, so it opens up. So the graph of this is going to look something like that. And notice I don't know where that is yet, but I do know the x-intercepts. And every single parabola is defined, 3 points define a parabola. If I give you 3 points on the XY coordinate plane, that is enough to define a specific parabola. An exact, there's only one, if I give you 3 points, there's only one parabola that satisfies those 3 points. All right, so that's the second most important format. And then the standard format was what you were getting the quadratic formula mixed up as. And this is,
Oh, that's what I was saying
yeah,
instead of the
that's
quadratic
the
formula.
standard format. In other words, they may give you an equation like this.
And that's in standard format.
That's in standard format. And notice that I don't even know where to begin graphing that because I don't know where the vertex is and I don't know where the intercepts are. So I've got some work to do on graphing it when they give it to you in standard format. And one of the things that you want to memorize is that the x coordinate of the vertex is equal to minus b over 2a. And if that looks familiar, it's because it's from the quadratic formula. Remember what the
Yeah.
quadratic formula is, minus b plus or minus
Minus b
square
plus,
root,
oh, sorry.
plus or minus the square root of the discriminant, which is under the radical. That's called the discriminant, all of it over 2a. Well, if you take just the first half of that, you get that. So if I wanted to know where the vertex of that bottom equation is, minus, this is b, 3, so it'd be minus 3 all over 4. So there is my x coordinate of the vertex. Once I have, excuse me, uh, that should be an x, not a y. In other words, it's the x coordinate of the vertex is equal to minus b over 2a. And the y coordinate of the vertex is whatever y is equal to when you plug in the x coordinate for x. In other words, if I plug in this minus 3/4 for x, I will get a value for y. That's the coordinate. That is the y coordinate of the vertex. So if they give you a quadratic in standard format, you can use this to figure out its vertex. You got to have a starting spot on where to start your graph. And usually the best starting spot is the vertex. So once you can locate, in other words, if they give it to you in this format, it's really easy because you know immediately your vertex is H comma K. And if they give it to you in this format, it's pretty easy. You know where your x-intercepts are. And if I know where the x-intercepts are, I know my vertex is exactly halfway in between those two x-intercepts. So I know where the x-coordinate is, even if they give me this. I can figure out the x-coordinate pretty easily. But if they give it to me in this format, it's a little harder. You got to start with the x coordinate of the vertex and then plug that into the equation to get the y coordinate of the vertex. All right. I can't remember how much of this we went over. Um, but I won't spend a whole lot more time on it. If we've already been over it once, then that's as good a review as you probably need for the moment. So let me look for some more stuff in my algebra book. Completing the square. That's a topic that will last us an hour. Have we done it?
Completing the square?
Uh-huh.
That rings a bell, and I'm not sure why.
All right,
Hold on.
let's do one.
I feel like I know how to do completing the square, but
All
isn't
right.
it just where
If I
like
gave you
you
this,
have hold on, one of the questions on the homework that you gave me was completing the
yes,
square.
I know. I saw that after I sent it to you.
49 minus 100a squared.
Okay. Let's start from scratch. You don't need to look at that one. Uh, here's how you complete the square. In other words, if I were to try solving this, I would move the 7 on the other side. I would figure out that I can't factor it quadratically, and I would use the quadratic formula. But there's a fifth way of solving it without the quadratic formula. And that's by completing the square. And completing the square is a technique that you will use for a lot of other math problems in the future. So it's not used just for solving quadratics. So you do need to learn it. When you get into conic sections, it'll be a big factor. So let's teach you how to complete the square. So first of all, to complete the square, I'm going to put parentheses around that. And I'm going to leave that 7 on the right side of the equation. And what I'm going to do is complete the square inside the parentheses. Well, how do you do this? You take half of that and square it. What do you get?
Um, Wait, 2 squared.
You get 4. And whatever you get, you
Yeah.
add to that. The second thing you do is because I've now changed the equation by adding a 4 to the left side of the equation. So to balance it, I got to add a 4 to the right side of the equation. Now I haven't done anything different. In other words, whenever you're solving a math problem and you're going to go down with rows, most important thing is make sure you haven't changed anything. You can't just add 4 to the left side of an equation without adding the same number to the right side. So when I wrote in that plus 4, I had to balance it by writing a plus 4 on the other side. And the reason that you complete the square in this manner by taking half of this coefficient and squaring it is that I can now write that as x minus 2 quantity squared. This becomes a perfect trinomial, which can be written as a linear term squared. And the other side becomes 11. And now I can solve this problem by taking the square root of both sides. If I take the square root of the left side, what do I get?
Um, Square to the left side, you
No,
get x minus 2.
exactly. And when you take the square root of the right side, you get plus or minus square root 11. Now, I would say that at least 75% of my students over the last 14 years cannot remember to write that plus or minus. I don't know why, but it's one of the most common mistakes you see people make in algebra. And what I tell people, which obviously isn't that effective because I just isn't, but what I tell them is that every time you solve an equation by taking the square root of both sides, which is what we did here, start your answer with the words plus or minus every single time. So we're solving this by taking the square root of both sides. So I'm going to start the right side out with the words plus or minus. Now I can solve for x. X, I'm going to take the 2 over to the right side. I'm going to put it in front. And the reason why I put it in front is probably obvious to you. That looks an awful lot like I used the quadratic formula. And in fact, the quadratic formula was derived by completing the square from the standard format. That's where it came from. So if you ever, and just this is worth knowing actually, if I write the standard format, which is this, and I want to solve that, I can use the quadratic formula, or I can move the c to the other side. Watch what happens. I'm not going to go through the whole thing, but you're going to see how the quadratic formula is created. Then I'm going to complete the square here. So what would I get? I would get, well, first of all, oh yeah, okay, let's go back. We didn't quite finish completing the square. There's bigger things at play here. Let's take, well, let's just do one more easy one. So complete the square on the left side. And what you always add, you're never subtracting this third term. I'm always going to add half of 5 squared. What is half of 5 squared?
Half 5 squared.
First of all, what's half of 5?
Wait,
Put it as a
half
ratio.
of 5 is 2.5.
Put it as a fraction. 5
Two and a
halves.
half.
No, 5
5
halves.
halves.
I should have said put it as an improper fraction. Improper fractions rule. They are so much better than proper fractions. The reason is,
Really?
yeah, here's why. Square that. Can't do it. Square that. It's harder. Square this. Piece of cake.
that is a lot easier than working with 2.5
That,
or 2.5.
that's why you should always work in improper fractions, never proper fractions. No matter what you're doing in math, always work with the fractions if you can. So I have to
All
square
right, I'll
this.
remember that.
So it's going to be 25 over 4. Now I have to balance by adding 25 over 4 to the right side. And now, because I completed the square, I can write the left side as x. And this sign right here is always the same as that sign. So it's x plus the 5 halves, quantity squared, equals, well, this is 40 over 4. So this is 65 over 4. Take the square root of both sides and you get x plus 5 halves equals, what should I start my answer with?
Plus minus.
Square root of 65 over 4. I'm going to write it like this for the moment, but that's the same thing as plus or minus the square root of 65 over the square root of 4, which is 2. Now, can the square root of 65 be simplified? Is there a
Square root of
factor?
65.
Yeah. Is there a factor of
No.
65 that is a perfect square number? No. It's really a good thing to know your perfect square numbers. Over here on the far left. These are your primary. If you know those 5 perfect square numbers, you'll be able to simplify most any radical. 65 is not divisible evenly by 4 or 9 or 16 or 25 or 36. Therefore, it's not simplifiable. And my final answer is, got to move this 5 halves over. So it becomes minus 5 halves plus minus root 65 over 4. Or excuse me, over 2. And there's your answer. And we got it without the quadratic formula. We got it without factoring. We got it by completing the square. Now, completing the square gets a little harder. We want to teach you how to do a harder one. This is actually significantly harder. Okay, so we're going to complete the square, but you cannot complete the square when this number that I'm pointing at is not a 1. If it is not a 1, then you have to factor it out. And you factor it out whether it divides evenly into 3 or not. You still have to factor it out. So I'm going to factor a 2 out. What that leaves behind is x squared plus 3 halves x. So I still haven't changed anything. This row is identical to that row. By identical, I mean if
It equals the same thing.
it's the same thing. If I multiply 2 by this, I get that. So I haven't made any changes. I haven't made any mistakes. The reason you want to check it every time you do something is so that you'll catch your mistake when you make it. This might
Otherwise, you have to
this might have
go back
11
like
steps in
16
it.
steps and erase
Yeah,
everything.
exactly. When you get if you go through 11 steps and you get the wrong answer or a nonsensical answer, You know you've made a mistake, but you got to go all the way back to the beginning to find it and just basically redo the whole thing. Whereas if you check at each step of the way, you'll notice when you make a mistake. So I can
Yeah.
by that too, and I can see that, yeah, I've got what I did. Okay, now I want to complete the square inside the parentheses because I now have a coefficient of 1 in front of my x squared. So I'm ready, I'm able to complete the square. So what do I need to add?
Um, 5.
Take
No,
half of this coefficient. What's half of that coefficient?
half of 3/2.
Uh-huh. 1
Wait a
half,
minute.
1 half times 3 halves.
Um, 3/4.
Okay, now square that, because that's what we do. We take half of that and we square it.
So 3/4 squared.
Just square the top, square the bottom.
9/16.
That's how much easier it is when you leave it as a fraction as opposed to 0.75 or whatever. Always work with fractions if you can. So I just added an amount to the left side of my equation. When I wrote that in, I added an amount. What amount did I add?
9/16.
No.
Or
What's that 9/16 being multiplied by?
2.
Huh. So I really added 18/16.
Or 2 and 2/16. Or 2 and 1/8.
Let's not use proper fractions ever. How about
All
nine?
right.
How about 9/8? Right? 2 times
Yep.
9/16 is 9/8. So to balance, I have to add 9/8 to the right side, not 9/16. I have to add whatever that times that is. If I would have factored out a 3, then I would have had to add 3 times whatever I wrote in there to complete the square. Okay, we're not quite done. So the only thing I know at this point is that I'm going to be able to write this thing right there as a perfect linear term, which would be what? X plus what?
X plus. Wait.
What you get when you took half of that. That's what you're always putting down here.
Oh. 3/4.
Okay. Now that left side is the same as this left side. And I have to change the right side. I'm going to add a whole number to a fraction. So I'm going to convert this 5 to some number of eighths, which is 40 eighths. So I end up with 49 eighths over there. Now I can divide both sides by 2 to get rid of this 2. So this becomes, instead of 8, 16, when I divide both sides by 2, gets rid of the 2 over here. That turns into 49/16. Now I can take the square root of both sides. So I get x plus 3/4 equals what?
X plus 3/4 equals 49
What are the first words you always need to start the thing with?
plus minus 49 sixteenths.
No, it's the square root of 49/16.
Oh, plus minus, um, well, I'm blanking. 7/4.
Okay, now I'm going to move the 3/4 over. So, in a different color here, because I ran out of room, I'll write the answer up here. X equals minus 3/4 plus or minus 7/4. And look what happens. That is our answer, but what does that mean, that answer? Let's figure out both solutions. Didn't mean to erase that. I want to get rid of all this. And this was, again, 5x. And what was on the other
It was
side?
3x, I thought.
No, it was 5. Um, oh, you're right. It was 3. This one was 5.
Yeah.
Okay. So what does this mean? What are both solutions? Because this plus and minus tells me I have two solutions. One solution is when I use the plus. The other solution is when I use the minus. So what are my two solutions? Use the plus first. Tell me the answer.
The plus, hold on.
Minus 3/4 plus 7/4.
Minus 3/4 plus 7/4 is, well, since a minus, wouldn't it be 7 minus 3?
Hold on.
Or
Minus over here on the
it's
left.
negative 3 plus 7, the same as 7
3/4
minus 3.
plus 7/4. Got the same denominator. Just add the numerators. What do
Or
you get?
fourths, or 1.
1. Now do the minus part. What do you get?
Um, negative 11/4.
How about negative 10/4?
Oh, geez. Okay, you didn't hear that. That didn't happen.
Negative 5/2.
Sorry, I got up really early this morning and I was at sports
I don't
practices all
care
day.
about your arithmetic. I mean, I do. That having good foundation in arithmetic is the most important skill you can have in math. Is to be able to
But I
do
mean,
stuff like
I hope
that
you know
without
that I know
without a
7 plus
calculator.
3.
What's that?
I said, I hope you know that I know how to do 7 plus 3.
I'm not worried about knowing 7 plus 3, but minus 3 minus 7 gives a lot of
That's the
people.
same thing, though.
Huh?
It has the same answer almost. So
Yeah. I'm
when
just
I
saying,
see
I'm
minus 3
just
minus
saying that
7, I
most people that have problems in math stems from them not having real strong arithmetic skills. So
I have stronger
I
arithmetic
believe you do also.
skills. I
Not
promise.
not worried
I don't know
about
what
your
just happened.
not worried about your arithmetic skills. Okay, so that's how you complete the square when there is a coefficient other than 1. You have to factor it out, and it doesn't matter whether it divides evenly into 3. You still have to factor it out, whatever it is. In other words, if I had some ridiculously complicated, I'm not going to go through the math of it, but just to show you what can happen. Let's say I have 7x squared minus 17x equals 2. Well, I've got to factor that 7 out. And leave room to complete the square. Now I got to take half of that, which is 17 over 14. In other words, whenever you're taking half of a fraction, just double the denominator, and that's your answer. Then I have to square that. So it's 17 squared over 14 squared. And then I have to balance by not adding that number to the right side, but adding 7 times that number to the right side. So whenever you get numbers, any big numbers at all, this thing gets wildly complicated doing the arithmetic. So rather than complete the square, I would not complete the square on this problem. I would move the 2 to the left side and use the quadratic formula. Far easier than going through the complete the square process. But like I said, completing the square is a skill you need to know to advance in math. You need it in a lot more places than just solving quadratics. But that is like the fifth option. I guess in addition to these four, dopes, quadratic factoring, and quadratic formula, there's also a fifth one calling square root of both sides. This is actually one of the easiest ones. If I give you a quadratic that is this is simple. This is a quadratic because it's got an x squared term. What's missing is there's no x term here. So how would I solve this?
Um, would you just do the square root of on each side?
Okay, so tell me the answer.
X equals 5
Nope.
plus minus 5.
If you left off the plus minus, you're going to lose half credit on the test. Guaranteed.
All right, I have to work on that.
Okay, now there is another way to do this problem so that you don't ever miss this plus minus. This is the simplest way, but watch what happens if instead of taking the square root of both sides, I move the 25 over to the left so that now I have this. And now notice that it's dopes. It's the difference of perfect squares. I know how that factors. How does that factor?
Um,
X squared
well, I'm
minus,
blanking right now. X minus 5, X plus 5.
and since that's equal to 0, you set each one of these equal to 0. This produces a solution of plus 5. This produces a solution of minus 5. And so you get your two solutions. And there's no way you can make a mistake. It's a little easier to just take the square root of both sides, but when you do that, you run a danger of forgetting your plus minus sign. And most people do forget it. I'm not going to lie to you. Smart people, and it's not just mediocre students that forget it. It's just something that's hard to remember, to always. And it's only when you solve an equation by taking the square root of both sides. If I ask you what is the answer to that, what is the question? Or what is the answer?
5.
You're right. That's not plus or minus 5, it's just 5. If
Yeah.
I want minus 5, I would have put it like this. And then that is 5, and so the answer would be minus 5. But this is just a convention. When I write it like that, I am saying, what is the positive square root of that? That's far different than solving an equation. when I have an equation, x squared equals 49, I've got to solve it by taking the square root of both sides. And now this left side becomes x, but the right side becomes plus or minus 7 because I was solving an equation by taking the square root of both sides. That's the reason. That's the difference. All right. Let me see if I can find a little something to end on here. You familiar with absolute value?
Yes. It's the two lines. That makes me sound so stupid, but I don't know
No,
how else to describe it.
there is no other way. That's fine. So how would I solve this?
Um, you would have x minus 2 equals -6, right?
Actually, the
Or
very first
just,
one you write should just be write it exactly as you see it without the two lines.
and
But
then
there's
x
a
plus 2.
second, and you want to use the word or, not and, but or. What's the rest of it?
X plus 2.
No, never change what's inside the absolute value.
Oh, sorry. X minus 2 equals -6. Sorry.
There you go. So this one solution is 8, and the other solution is -4. And if you plug 8 in, you'll notice that the absolute value of 6 is 6. And you'll notice that the absolute value of -6 is also 6. In other words, if that's what absolute value means, is whatever the positive number is. It's real simple, actually. They can, I won't get into that. They can kind of trick you up a little bit. I will get into it. So let's solve this one. That's a good one to end it on. End tonight's session on. So solve it just like we did the other one, first of all. So give me your two
X
possible,
minus 2 equals -3. And,
or, not
or
and, or. There is a mathematical difference between the two words. Very important.
x minus, or x minus 2. Okay, I feel like if I say equals 3, I'm gonna be wrong.
Well, no, you're doing it by the format and the method that I just taught you.
Is it?
This would yield a solution of -1 there, 5 here. Plug those in. Does this one
5
work?
minus 2 is 3, so that does give the solution of +3, -1. Minus 2 is -3.
So do these solutions work?
Yes.
No, they don't. We'll take this solution first. Plug in 5. The absolute value of
5 minus 2.
3, yeah, the absolute value of 3 is not -3. It's +3. And the absolute value of -3 is also 3. It's not -3.
Oh, I just got confused and I
So
thought
what's
that we
going
were
on
doing
here?
like,
Well, what's going on? This is a trick question. It's a trick question because the absolute value of anything always has to be positive. And I gave you a problem that said the absolute value of this was equal to -3. That's impossible to begin with. And so
absolute
if you
values can't be
notice
negative.
that, if
I'm
you
getting such a
notice that
refresher right now because I haven't done absolute values in so
right
long.
off the gap, that's the answer, no solution. I don't have to go through those steps. It can be easy. They'll throw in a trick question like this every now and then in this absolute value section. I had an eighth grader once who had an absolute value problem just like this. And I went through both solutions. Like I didn't notice that it was a trick question and couldn't figure out what was going on. But yeah, whenever they give you something like that, that's an impossibility. All right. Good place to end. So are we going to have a session next Thursday?
Yes.
Okay. So I'll leave you on the docket for next Thursday. And in fact, I'll leave you on the docket until you tell me to take you off for regular
Alrighty.
Thursdays. Okay. So I
Yep.
will talk to you next Thursday at 6:30.
Alrighty.
Okay. Thanks. Bye-bye.
Thank you.